All right. Good evening, everyone. So we're working on chapter 5, homework 6 for our lesson. It looks like there's only one page, but we still got three problems. So, right. So, number 86. Identify the following sequence as arithmetic, geometric, or neither. For arithmetic and geometric sequences, identify the growth pattern. Right. So, we will need to pull up our calculator. Okay, and actually, let me do this. We need a calculator over here. Okay. Excuse me. Okay, so like how I showed you guys in class, if you want to find out if something's a arithmetic, you need to take the previous term and subtract that from the first term. So we want to see if it's arithmetic or geometric, and if we let's say we don't know what the pattern is, right? So let's just say, we're going to go 144 minus 12, right? 144 minus 12. So we'll do that. So we'll go 144 minus 12, and we get 132. So with that pattern, we're saying that this pattern is, we're saying it's arithmetic, meaning adding or subtracting the same thing. That means that we're adding 132. Okay. Now we got to do the next one. So we're going to go ahead and do the same thing. We're going to start with the bigger, or the not big, not necessarily bigger, just the term that's further on. So 1728, and we're going to subtract 144. So 1728 minus 144. And if it's arithmetic, that means that it's going to give me the same thing. And if you notice, it's not. Okay, so the first time we're adding 132, and the second time we're adding 1584. So this is not arithmetic. So we're going to scratch that. So it's not plus 132. Okay, now we're going to see if it's geometric. And geometric, we're going to do the same thing. We're going to start with 144, and we're going to go ahead and divide it by 12. So let me start over. 144 divided by 12, and we get 12. So that, which means that to get from 12 to 144, we're multiplying it by 12. So we're multiplying it by 12. All right. Now we want to check out the next part, from 144 to 1728. So we're going to go ahead and take the number that's further along, 1728, and we're going to divide it by 144. Okay, so 1728 divided by 144. And lo and behold, you see how I get double 12s? That means that I found a pattern. Okay, the pattern is times 12, and then the next one is times 12. All right, so this one is going to be geometric. All right, so I'm going to go ahead and say letter A is geometric. Okay, and then the growth pattern is, so it's growing by multiplication of 12. Right, so for excuse me, for for I forgot what I wanted to say. Um, for arithmetic, right? It's called a common difference, and we use the letter S for that. For geometric, it's called, I forgot what it's called, but we use the letter D for that. No, I think common difference we use S. For geometric, we use, I forgot what we use. I think we use S, right? And that S, that's the growth pattern is going to be times 12, or just write 12 down. Right? That's it. Okay, so let's check out the next one. Okay, so again, I'm going to go ahead and check it out, see if it's going to be arithmetic first. So from 0 to 5, so I'm going to go 5 minus 0, and I get 5. And I'm going to do the next two numbers. I'm going to do 10 minus 5, and I get 5. So that means that I've actually found a pattern. So this from 5, so from 0 to 5, I'm adding 5. From 5 to 10, I'm adding 5 again. And you can see each one you're adding 5. 15 to 20, add 5. And you do the subtraction of it, you'll see it. Okay, so one thing to keep in mind for for arithmetic, you do the 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 latter term subtract the earlier term, and you always do subtraction. And if you get a positive number like 5, that means you're adding it. If you do the latter term subtract the earlier term, you get a negative number, that means you're subtracting. Same thing with geometric. Okay, you're always doing division, and if you get a decimal, then that means that you're actually doing a division of it. If you get just a whole number, that means you're doing a multiplication. Right. So in this case, we have an arithmetic sequence. Okay, and this one, our common difference is 5. Okay, we don't have to say plus 5. By saying arithmetic and using the letter D, we are actually saying that we're adding 5. So we don't need to actually say plus 5, or we don't need to say times 12, because when we say geometric, and we say S equals 12, it automatically means times 12. Okay, see? Okay, so again, if I'm going to try this out. If I go 0 plus 4, right, which may works, but 4 plus 4 does not make 16, so we know that it's not arithmetic. Okay, and if you try it on the calculator, right, 4 divided by 0 is 0. 16 divided by 4. Oh, what happened? So 4 can't divide by 0. Sorry, but 16 divided by 4 is 4. Okay, and 36 divided by 16 is 2.25. You see how it doesn't work out, right? And we can do subtraction, but it doesn't work out either. So this one is in neither. Okay, and since it's neither, it doesn't have a common difference or a common multiplier. So we don't do S or D because it's neither. Okay, letter D. So I'm not sure what's going to happen, but I'm going to go try arithmetic first. So I'm going to go with a slightly bigger number, 2.25, and I'm going to take away the earlier number, 1.5. Okay, you get 0.75. Now I'm going to do the next one. So 3.375 minus 2.25. And you see how it doesn't come out to be the same number? So by doing the subtraction of it, by me testing 2.25 minus 1.5, and I get 75 up there. And then when I do 3.375, take away 2.25, and I get 1.125. You see how when I'm doing the subtraction of it, I should be getting the same number if it is arithmetic, and it's not, because I'm not getting the same number. So that means that it's not arithmetic. Okay, then I'm going to go ahead, clear out my calculator, and I'm going to go ahead and try to see if this is going to be geometric by taking the latter number, the 2.25, and dividing it by the earlier number, 1.5. So 2.25 divided by 1.5, and I get 1.5. Then I'm going to do this again with these two numbers right here. Okay, I'm going to go with 3.375, and I'm going to divide it by 2.25. You see how it matches up, it works. So then I know that this right here, this pattern, is geometric. And I can even try it with a 5.06. So 5.0625, and I'm going to divide it by the slightly smaller one, 3.375. 5, and you get exactly 1.5. So I know that this one I'm going to put in blue because it is geometric. So I know that to go from here to here, I'm going to multiply by 1.5. From here to here, I'm going to multiply by 1.5 again. Then here to here, I'm going to multiply by 1.5 again. So this one is a geometric. Okay, and my S, or my growth pattern, is going to be multiplication by 1.5. And all I need to do is just write down 1.5. Okay. Write the first 5 terms of each recursive defined sequence. Okay. So number 87. So on each of these, I'm going to use 3 different colors. First one, the first term is already written for you. It's -3. Okay. Next term is, we're going to go ahead, and this one says to find out my next term. So that's term 1 right here, right? So if I want term 2, I need to put a 1 right here, because 1 plus 1 would be 2. And if I put a 1 right here, that means that I'm looking at term 1, which is up here. So T1 is -3. See that? So T1 is going to be -3. So if I want term 2, because 1 plus 1 makes 2, right? So if I want term 2, I need to put a -3 right here. So term 2 is going to be -2 times -3, which is +6. Okay, that's term 2. Let me write it down. Well, actually, I don't need to write it down. Okay, and if I need term 3, because I need to find 5 terms, if I want to find term 3, I need to put a 2 right here. Right, that means I got to put a 2 here. So term 2 plus 1 makes 3. Right, if you look at 2 plus 1, which makes 3. So term 3 is going to be -2 times term 2, and term 2 is right here. Right, so -2 times term 2, and term 2 is 6. So I'm going to put a 6 right here. So -2 times 6 is going to give me -12. Right, and once you figure out the pattern, you don't need to rely on this recursive formula anymore. But if you still need it, so for this first one, I'll just go all of it out of that. Right. So if I need my 4th term, right, because this is 1, 2, 3, and if I need to find my 4th term, I need to use 3 right here, because 3 plus 1, right, 3 plus 1 is going to give me 4. So if I use n equals 3, I'll get 4 right here, and my n would be 3 still, which means I'm looking at term 3, T3 right there, and term 3 is right here, right, which is -12. So term 3 is going to be -12. So I'll have -2 times -12, which makes +24. Okay, and if I want to find term 5, right, term 5, 1, 2, 3, 4, 5, I need to use 4 right here, because 4 plus 1 makes 5. So if I use 4 for n, that means that 4 is going to be right here, which means right here means term 4, which is 24, right? So term 4 is 24. So I'm going to put 24 right here. And term 5 is going to be -2 times 24, which is again going to give me -48. And that's term 5. So my terms are -3, 6, -12, 24, 48. Okay. B. Okay, so term 1 is 8. That's what it says right here. Term 1 equals 8. And to find term 2, you got to put a 1 in place of the n, which means I put a 1 here, right? So t equals 1, or t of 1 plus 1. So 1 plus 1 makes 2. So T2, or term 2, is going to be term 1, which is right here, which is 8. So it's 8. So term 2 is going to be 8 minus 5, which makes 3. Okay. And if I want to find term 3, I need to put 2 here because 2 plus 1 makes 3. So term 3, that's if I put a 2 in place of the n. So term 3 is term 2 minus 5. So term 2 is right here, which is 3, and 3 minus 5, right? So term 2 is actually 3. 3 minus 5 makes negative 2, right? And then on this one, I'm recursive, and you guys know how I feel about recursive, and we talked about it plenty in class, but recursive is a little tedious. So once you figure out the pattern, okay, it looks like we're subtracting 5, right? 8 minus 5 is 3. 3 minus 5 is negative 2, right? And the pattern is right here anyways, right? So 8 minus 3 is 5, minus 3 is 2. Oh, 8 minus 3 is 5. It's not minus 3. It's minus 5. 8 minus 5. That's what I meant to say. 8 minus 5 is 3. 3 minus 5 is negative 2. So it's minus 5. That's where I went wrong. So 8 minus 5 gives me 3, which is the second term. Minus 5 gives me negative 2, right? So I have the pattern going. And since I have this going, and I already have answer minus 5, I can just keep hitting enter. So that's my third term. My fourth term is going to be negative 7. And then enter again. My fifth term is negative 12. That's all I need. So for recursive, if you can get a couple of numbers going, then you can just go ahead and get the rest of them in by figuring out the pattern. Okay, we'll use blue for this one. Okay, first term, T1 equals 2. Right, so the first term is 2. Right, so if I want to find the second term, I have to put a 1 right here because 1 plus 1 would be 2. And then that means I put a 1 right here. Okay, so I get term 1 plus 1 is 2. So term 2, excuse me. So term 2 is equal to term 1, which is 2. So this is just 2. And then that's the inverse of that, or negative 1. Negative 1 just means you flip it around if it's a fraction. And in this case, we can make anything to a fraction. So that's going to become 1/2. Okay. So that's term 2. To get term 3, I need to put a 2 right here because 2 plus 1 would be 3. That means that I put a 2 right here for the n. Right? So the n is going to be 2. Okay, so term 2 plus 1, right, that makes 3. So term 3 is going to be term 2, which is 1/2, and I flip it around. So term 2 is 1/2. So you think about it. Term 2 is 1/2. So 1/2. And I do the negative 1, which means that it changes it back to flip it around, which means it comes back to 2. So I'm like, okay, I think I got this. And the next one is going to be 1/2 again. And the next one's going to be 2. So it's going to keep flipping back and forth like that. All right, and if you want to double check it, you can do it like this. So you got 2, okay, and you take to the negative 1. That makes 0.5, and we know 0.5 is 1/2. And then we take that right there, we do the inverse of the negative 1, which we get 2. All right, and then we're going to hit enter. 0.5, 2. 0.5, 2, and it's going to keep flipping back and forth like that. All right, so that's the pattern for C. Okay, last one, number 90. Simplify each expression. And this is actually from a while ago. Right? So, working on this, looking at each parentheses, there's nothing on the outside, right? Nothing out here. So I don't need to worry about that. And looking at this parentheses, there's nothing on the outside. So I don't need to worry about that. So I just need to go ahead and multiply my numbers together. So 2 times 4, that makes 8. Okay, so took care of the numbers. Now we got to take care of the variables. We got m to the third, and remember when we first started doing this, we did a brute force method, meaning we just kind of just write it for what it is. So m to the third is really m times m times m, right? And the m to the second is m times m. So together, if I multiply them together, I get m, and if you count them, 1, 2, 3, 4, 5, you get m to the fifth power. Okay. Okay, next one. Okay, again, nothing on the outside of the parentheses. In fact, there's no parentheses, so you're just going to go ahead and you know what? Let's do this the old-fashioned way, right? Let's do this brute force method. So 6 looks like this, and y to the fifth looks like y times y times y times y times y divided by, and this is only division because there's a division right there. Okay, this on A doesn't have division, so we don't do any division. I noticed that on some of your past quizzes, you guys kept doing division even though there wasn't any fractions. Okay, so next one, the bottom is going to be 3, and then you get y squared. So y times y, right? And now you're going to go ahead and play with this. So 6 divided by 3, that makes, here, I'll put it up here. That makes 2. Okay, and the y's, this y right here, cancels out with that y, so no more. This y cancels with that y, so no more. And then we're left with 3 y's on top of a fraction. So this 2 is actually on top of a fraction because it's 2 over 1. Right? So we have 3 y's left over. So I'm going to go ahead and just write y to the third. And that's on top of the fraction, which means that it's just 2y to the third. Okay, I'm going to do the same thing for this one right here. This is, and because it's a fraction, I'm going to write it as a fraction. Negative 4y times y. And this bottom is 6 times y times y times y times y times y times y times y. Okay, and you're going to go ahead. I'm going to go ahead and cancel my y's out. And my y's out. Okay, but 4 and 6, I can divide each of them by 2. Negative 4 divided by 2 gives me negative 2 left over. 6 divided by 2 gives me 3. Okay, and if you look here, I have 1, 2, 3, 4, 5 y's left over, which is on the bottom. So y to the fifth. Okay, and lastly, D. Notice that, okay, there's no fraction, so I'm not going to write it as a fraction. Okay, but I do see that I have my parentheses with a 3 on the outside, which means that I'm going to have 3 of those. So I'm going to do this the old-fashioned way, or the brute force method, which is I have a negative 2 x, x, and there's 3 of those. So negative 2 x, x, and then another negative 2 x, x. Okay, that's what the little 3 on the outside means, is I have 3 groups of those. Oops, negative 2xx. Okay, and then I'm going to go ahead and just combine what I can. So I have a negative 2 times a negative 2 times a negative 2, right? So negative 2 times a negative 2 is 4, and then 4 times negative 2 is going to give me negative 8. And then I'm going to see how many x's I have. I have 1, 2, 3, 4, 5, 6, and I'm just multiplying them together, no canceling like how B or D is. So I have a total of 6 of them. So I'm going to have x to the 6th power, and that's my answer. All right. That's a wrap, folks.